First, just a little bit more about Kinnext as a team. We're a Web3 service provider. We're focused on Web3. We want to build the graph community through Web3. We are a graph indexer, so you can definitely find us and delegate to us if you like. As a team, we've decided to manage our own bare metal hardware infrastructure. So we lease space in data centers. We buy our own servers and manage them that way. We've been operating Firehose for more than 3 years. It has been around a long time, although in the graph ecosystem, we haven't talked about it for 3 years, but the tech that goes into building Firehose has been around for a long time. Kinnext as a team has 7 co-founders, and we're headquartered in Canada, and we're a growing team. We're approaching 50 members now, so it's great. As Christina mentioned, Chris was instrumental in helping getting this presentation going. So you may have seen him at ETH Denver here, and here he is with a bunch of the other graph ecosystem participants, earlier this month. So you may see us at more events in the future with, the Firehose helmet or Fire helmet. So today, here's the kind of high-level overview. Why is Firehose needed? The architecture, substreams, and then why do we need Firehose and substream for different kinds of users? So decentralized applications, developers, the blockchain community in general, and of course for indexers as the technical operators within the graph ecosystem. Indexers are very important to the Firehose story. So who built Firehose? Well, Jimmy Fast team. So this is the co-founders of Jimmy Fast. So they've been building the technology behind Firehose for many years now. And so we've worked closely with them over time. So why do we need Firehose? So let's start with this big question. So let's imagine we're going to do a little story here. This is all the Ethereum data in the world represented by this ocean. And, if you're using the graph today, it's possible to figure out how to get the data that you need in an organized fashion in a graph from the Ethereum community. Of course, it works on other blockchains other than just Ethereum, but we started with Ethereum, so here's the picture. So moving forward, the future is multi-chain. And multi-chain doesn't mean just like 5, 6, 7, 8 blockchains, whatever we're up to on the decentralized network now, or 30 blockchains that's on the hosted service. It's hundreds. It's going to be huge, where the future is huge amounts of blockchains. And the data in each one of those blockchains keeps growing. So this is the mind-blowing emoji. It's just unimaginable, the amount of data that's coming and the amount of processing to handle all this stuff. So this is where we need Firehose. So we got a little surfer dude here. He's got his straw trying to get all of the data out of all the blockchains. So in fact, we could really think about it as multiple straws. So here's the stuff I need exactly from Firehose, from Ethereum. Here's the ones I need from Solana. Here's what I need from Near. Here's what I need from, Juno or Cosmos, whatever blockchain stack. The idea here is we're going to generate you a super magical straw that just gets you the data you need from the blockchains that you want and organize it how you want. So developers need data in different formats depending on which problem they're trying to solve. And we'll go into more about this later. But a developer who wants to generate a, stock ticker on their website showing live data about what all the transactions are needs a very different set of data compared to a developer who's trying to do deep AI analysis on what is the, biggest whale in the system and who do they interact with, right? Very different kind of use cases, and the developers need the data in different formats. So the Firehose is also meant to make it easier for the developer or the indexer backend. So managing all of the infrastructure to index blockchains, the way it works in the graph ecosystem today, it's hard. So as a team, we've been participating in the MIPS program, and you look at the other MIPS participants, and it's like the discussion on Tuesday during indexer office hours was like, it's a full-time job just reading Discord. Never mind actually doing anything, just keeping up with what's going on. And that's today, how many blockchains are in MIPS? It's like less than 10. And we're going to have hundreds. This is crazy. We can't scale the existing teams to manage this kind of situation. So anyway, different chains work in different ways. It's hard. They don't have common APIs. Scaling, like I was watching the Discord channel for the Aragon client. Aragon is used for the Ethereum-like blockchains. And somebody was like, this is not a graph person. This is just somebody else in the world running their own Web3 service. And they're like, I have to run like 40 Aragon nodes in order to scale. And then each one is not syncing. And it's just like, this is a big disaster. Anyway, Firehose is meant to really help with all of this problem. So scalable, stable interface is what we want. So where is Firehose available today? A whole bunch of chains. So Ethereum, Solana, Arweave, Near, Aptos, BNB Chain, Polygon, Cosmos, Osmosis, Junis, EOS, Wax, Telos. Maybe I forgot some, but it's available here today. And if you're using the hosted service, if you're using Studio, you are using Firehose today. If you're on Ethereum, Arweave, Near, Cosmos, Osmosis, all of those are using Firehose today. Whether you knew it or not, they are. The other chains that are coming, I think the next one will be Polygon. Certainly, we're working on Polygon on the decentralized network, providing the information to the indexers right now. So the indexers are learning how to run Firehose by using Polygon. So that'll be next. So it is working. It's live today. You can use Firehose on these chains. Let's just go into a little bit of architecture in terms of how all this put together. I got a few slides here, and they're just going to get a little bit more complicated to try to explain how, this is set up. So I've oversimplified this first slide. If you talk to an indexer today, this is kind of what they run. They run a whole lot of stuff, but at a high level, this is what they run. They run GraphNode. So this is the component that indexes all of the data and makes it available to the world through the gateway interface and the decentralized network. So indexes will run GraphNode. And then GraphNode needs to get the blockchain data from somewhere. So you have an archive node that's synchronized to the blockchain. So we're getting the data from the blockchain. It's in the archive node. The GraphNode then queries the archive node and stores the data in a Postgres database aligned to whatever the user requested in their subgraph. Okay, so I've left out a whole bunch of pieces there, but this is high level. All right, so now we're going to go to the next slide, where we're just going to insert Firehose into the mix here. So we still got the graph node, we still got archive node, but graph node can read data either from the archive node or it can read it from Firehose. So you have an option, and depending on which subgraph it is or which blockchain it is, you might use the archive node, you might use Firehose. So this is an option now for indexers. They can use either one. Firehose itself needs to still connect to a blockchain node. It doesn't need to be an archive node, but it needs to be some sort of node that knows how to read the blockchain data as and when it arrives. So Firehose itself doesn't know how to synchronize blockchain. It needs to work with something that's going to do that. And then I just put the consensus node in here. So, since the merge in Ethereum, you need a consensus layer client for Ethereum. If you're on other blockchains like, say, Cosmos or whatever, you don't have a consensus stuff. But this is the general picture. So Firehose comes into play. It can talk to the graph node. It can also talk to the user directly. So a user can directly interact with Firehose, or the user can interact with GraphNode and GraphNode interact with Firehose. So that's why there's kind of two arrows for the user, because they could go in either way. Firehose itself stores all of its data in what's called an object store, and I'll show an example of what that looks like in a minute. So now I'm just going to explode the Firehose box and just give you a sense of the components that are involved in Firehose. So I just took that one box that was on the last slide called Firehose, and I changed it into 6 boxes here. Right. So we've got on the right side, the reader component. So the reader component is the component that talks to the individual blockchain. So there's a reader that knows how to talk to, say, Ethereum. There's one that knows how to talk to Near. There's one that knows how to talk to Cosmos, etc. So there's a reader that's specific for each blockchain. And then the rest of the components are kind of the same. It doesn't matter. Once you've got the blockchain data into Firehose, we need to relay the blocks live. So this is where if you want to kind of build a stock ticker kind of thing, we don't want to keep requesting, give me the latest block, give me the latest block. You just want to feed. Just send me the stuff. So the relayer allows sending live data. So that's what the relayer does. The Firehose gRPC, this is the thing that actually the users talk to, the graph node talks to. So we have the Firehose. Substreams tier 2, this is the component that does the parallel processing. So once we talk about substreams, you'll hear about it's really fast. Well, the way it's really, really fast is you run, say, 30 of those substream tier 2 processes. This is massively scalable cloud environment. So run lots of substreams, you can get a really fast results. Merger and search index are kind of more technical components, but they're organizing the data so it's easier for those other components to use. I'll just kind of skip those for now. Right, so this is what the Firehose data format looks like. It's using a concept of flat files, which is really used in data warehouse kind of applications. So big data, if you're thinking about big data, flat files are great because you don't need an application that's serving out each file one at a time and that's rate limiting things and whatever. Flat files, they're just a directory that can sit on your laptop. It's fine. It's just a file, and they're organized by the block number that's in the blockchain. So the very first file is file 00000, 10 zeros there, and that represents blocks 0 through 99. If you want to get the block, you read it out of that file. The next file is 100. So guess what? It represents the blocks 100 through 199, and so on. So it's really easy to organize. You can transfer these files around. You can process them really easily. Some blockchains don't have blocks that go exactly in order. So it's not like 1, 2, 3, 4. Sometimes they skip 1, 2, 3, 5, 7, 12, 14, whatever. So in those cases, these block files here will contain less than 100 blocks. For Ethereum, we don't skip numbers. So you'll get exactly 100 per file. So that's how it works. So these just files, and we can transfer them around, share them, whatever. Makes it easy for indexers to cooperate with each other by sharing these files. Now, let's dig into a little bit of what is Substreams. So Substreams uses all of the Firehose infrastructure and allows us to just get the part of the blockchain that we need. So if we go back to that little surfer dude with his ocean and his straw, so this is the straw, right? Dear Firehose, I want OpenSea NFTs, and I just want mine. Forget everybody else. Just give me mine, right? So Substreams allows you to give me everything. Give me a little bit, give me a lot, whatever. It's very flexible. You can get whatever you want for your application. So this is the idea here. Okay, so the other thing is that substreams are composable. So this means that substreams can be built one on top of the other. I've got a picture coming up in a future slide, and I'll show you. Currently, if you're working on subgraphs in the graph ecosystem, if you want to leverage somebody else's work, you just have to copy it and modify it. You can't take what they've built and then build your thing on top of it. They're not modular building blocks. So substreams are kind of like Legos, and somebody builds a small thing, and then you can build on top of it, and somebody can build on top of yours, etc. So this is going to allow development to go much faster when we can cooperate as a community to build something. Substreams are parameterizable. That means, say I have a substream that knows how to do NFTs. Well, I just want my NFTs. So that would be a parameter. So I don't have to rewrite the whole substream. I don't even have to recreate it. I could just say, dear substream that already exists, just give me my NFTs. So it makes it easy for a non-programmer to get a custom Firehose feed or substream feed. You know, that straw is just for them because we don't have to program it. We can just provide the details of what exactly we want, given that somebody else has already programmed that substream. They're transformable, so we can change the output format. So currently, if we're using the graph infrastructure, we always get GraphQL. That's the only option, right? So if you want it as a data warehouse format, like a Parquet file, P-A-R-Q-U-E-T, there's no option for that with the graph. With substreams, it is. So do we want it in a key value star? Do we want it in Postgres? Do we want GraphNode to handle it? Do we want it in a CSV file? Do we want to send it to a Telegram bot? These are all options. So we can define how the data looks like when we request it. Very powerful for developers to get what they want in the format they want. And then, as I mentioned earlier, it's parallelizable. So if we run multiple of those substream boxes, and we have all these Firehose blocks sitting on disk, well, we can have one substream process blocks 0 to 1 million. The next one processes 1 million to 2 million. The next one processes 2 million to 3 million. And then once you have all these things doing their own bits and processing their own parts of the chain, then you can merge all the results together and give it back to the user. So the user using substreams doesn't have to have big compute infrastructure. They just need their straw. And the indexers who are providing the substream service, they have all of the massive infrastructure behind the scenes and making it easier for the users. And Substreams has been available for the last 2 weeks. It's considered generally available, which means it has a pretty stable interface. Developers should be able to use it. And in fact, If you deploy a subgraph that uses a substream on Studio, on Ethereum, it works already. So you can use it already today. So let's just look at the data pipeline for how substreams works. In computer science, we talk a lot about ETL process, extract, transform, load. Or in this case, I added query to the end, ETLQ, right? So Firehose is the extract. So there's a blockchain running. Let's get all the data that we need out of the blockchain, everything that we might possibly use. Start block, start transaction, change balance, end transaction, end block. But it's more complicated than that. But everything that you want out of the block, out of the blockchain you get, and we store in those flat files. We also stream it out using that relayer component. So we store the data in case somebody wants it later. We stream it out live in case anybody's trying to build that stock ticker and show the real time what's going on. Substreams takes the data that's coming out of Firehose and then transforms it, makes it look different. What do I need for my application? So we've got substreams transforming things either live or on the flat files that have already been created. And when a substream runs, it also keeps the results of what that substream did. So that's called a cached file. So it's like your browser cache. If you visit a website, the next time you visit that website, it kind of loads faster because there's a cache of that file sitting on your laptop. So it doesn't have to reload it, especially noticeable on a slow connection. So Substreams does the same thing. So the next developer who asks for the same substream that somebody already ran, guess what? We can get the results faster because they're already calculated. And that's really important when we build those Lego blocks that are composable. So if I build a substream on top of your substream and your substream already ran, well, guess what? Mine runs faster because now I can use the cache files that already exist. Very powerful. We have this concept of ETL, so load, the L. So we've got a substream sink. So a sink in computer science terms is just a destination to put data. So we're going to stick data over here. And as I mentioned, we can store it however we want. We can store it as in Postgres. We can store it in another flat file. We can do whatever we want. And then the Q part is the query interface. So if we're going to use the load and we're going to load the data into GraphNode, then we can query it using GraphNode. So the GraphNode is providing both the load and the query aspects. In that case, depending on other formats, the load and the query might be two different applications. Okay, so what are all the different kinds of sinks? I kind of mentioned a few of them. I would just put a kind of word cloud here. So you can put it in a Postgres database, like GraphNode uses Postgres database. You can put it in GraphNode itself. You can put it in a NoSQL database. You could put it in Prometheus. You could send it to Telegram. You could put it in a TideKV, Google Bigtable. The possibilities are endless, and the developers are busy writing new sinks all the time. So there's a few here to start with, but the world of sinks is going to get bigger and bigger. So as there's more demand for, well, I would like to have my data in X. Well, somebody needs to write it. And then boom, now everybody can use it. We're going to share these sinks. So I mentioned earlier, substreams are composable. So here's just a kind of picture of how that looks. So imagine all these little boxes are little substreams in themselves. And the different colors here are representing different authors. There's the purple author, there's the pink author, there's the yellow author, right? So different people have written different components. But, you know, at the end, somebody don't have to worry about how do I get all the OpenSea data out of Ethereum blockchain? Or how do I get the prices? Somebody already solved that. I'll just use the NFT feed, I'll use the price feed, and then I can build my substream that does just the part that I wanted. So substreams are composable, and if you're doing something like, say, Uniswap or something, you might have like 100 different components here that all need to work together. So let's just look at the developer workflow quickly for what a developer needs to do to reuse substreams. It's different than subgraphs. So you can't just, I have a subgraph, let's just make it a substream. Unfortunately, it's a different model, and you have to think about it in a different way because it has to work in a parallel fashion so that we can process block 0 to 1 million, block 1 million to 2 million, etc. So subgraphs were written in a kind of like they go in order. You start at the beginning and you go to current. With substreams, they have to be written in a way that allows you to split up the work so that it'll run fast. So unfortunately, you can't just take a subgraph you already have today and say, just let's run it with substreams. No, have to do some rework as a developer. Sorry, that's how it is. The code needs to be written in Rust. You can leverage other people's work. So we want to publish what you're doing, get other people to use it, etc. The code is compiled to WASM. WASM is web assembly language. That's the same thing that your web browser uses to run JavaScript to build nice interactive applications in a website. So code is written in Rust, compiled to WASM. That WASM bundle of code is then sent to Firehose. Dear Firehose, here is my WASM. Please run it. Then you're going to read the results as they become available and then do something with it. That something is up to you. You can store it in the sink. You can stream it live, whatever you want to do as a developer. So this is the kind of workflow that a developer has using substreams. So substreams are fast. So you listened to the Graph Core developer chat last week. You might have heard Robin from Messari say he took a subgraph and changed it to using substreams. So it's the same subgraph that provides the same output. He changed it to use substreams, and it went from the processing time went from 2 months to 1 week. This is huge, 8x faster. So you get the same result. It's still available in GraphNode. You can still query it the same way, but we got the results, 8 times faster. Very cool. Vincent from Messari. So Messari is doing tons of work with substreams here. Kudos to them. You can go look at their GitHub repo. They're doing lots of work. So back in October, Vincent from Messari said, I processed the entire history of Ethereum in 20 minutes. That's great. 7 years of data processed in 20 minutes. Awesome. But you couldn't do this before. All right. So let me just go through just a quick few slides that talk about, before and after. So before Firehose, RPC data inconsistency between different subchains. So it's okay if you're staying within Ethereum. Okay, Ethereum kind of works like Polygon, which kind of works like BNB chain, which kind of works like Phantom, which kind of whatever. They're kind of the same. But if you start changing, okay, I'm going to use Solana, I'm going to use Aptos, I'm going to use Antelope, blockchains look very different. And so as a developer, if you're trying to build a multi-blockchain enabled future website, well, this is really hard to deal with. So let's just make it all look the same. There's a Protobuf gRPC stream that comes out of Firehose. I know it's a bit technical. Don't worry. The whole idea here is get the same experience no matter which the blockchain that you're using when you use Firehose. Now, each blockchain is not the same. Some have different ways of representing transactions. They have different attributes. You have a consensus layer. You don't have a consensus layer. This kind of stuff. So the actual details are different depending on the blockchain, but how those details are presented to a developer is in a very consistent way. So it makes it much easier for developers. The RPCs, they're not fast enough. So if you're trying to do something like Uniswap, it takes a long time. They're just complicated. So when we can do flat files, data streaming, parallel processing, much, much easier, much faster, turn it around from a developer perspective. And so without Firehose, developers are sitting there waiting for results. It's wasting their time. Hey, let me change something, then wait months and see if it works. Really? Is that practical? I don't think so. Right? We need a much faster feedback for developers. So the solution here is server-side parallel processing. The idea is modeled after kind of Google BigQuery. Is kind of what we're going for here with Firehose and substreams. Reorgs or forks inside a blockchain, though those are hard to handle from a developer perspective. You have a block, then the block goes, just kidding. Here's the new block. So with Firehose, it has this concept of a cursor and it allows you to go forward and allows you to go backwards. Oops, I could undo the events and then you can go forward again. So Firehose handles that automatically for you, which is great. And the existing graph is great, but you can only do GraphQL. If you want an application that doesn't really fit with GraphQL, the graph ecosystem today using GraphQL is not really for you. So with Firehose and substreams, however you want it, you can use GraphQL or you can use something else. So this is the idea that we want to make it universal for any developer to do whatever they want. All right, so I'm just going to go through thinking about the Firehose and substreams in a different way, just talking about it from a different perspective from different communities. So let's talk about it from a DApp, decentralized application perspective. So if you're a DApp, you can use a substream and a subgraph. That's a simple use case. It already works today, no problem. You can stream directly to a website in real time, generate that stock ticker kind of thing, generate Telegram alerts, create an operational dashboard in Prometheus and Grafana. All these things you could do pretty much today. And our team as a development team we're working on making these kind of things easier. So substream and subgraph, that has been done by the core dev team in the graph. Our team has done the other ones and built prototypes to make so we can see all of those working. So those are kind of simple use cases. So a developer should be able to quickly execute on one of those. Or you could take it and do something complex and store it in some complex data service, redo things, mix between different blockchains. It's up to you what you want to do. So as a decentralized application developer, sky is the limit in terms of what data you want. You can get it in the format you need for whatever application you're building. And here's just some screenshots of what we're doing. So the first one on the left, this is a prototype screenshot. It's a live screenshot of a prototype of a Google Sheet. So can you imagine showing your blockchain data in a Google Sheet? You go in Google Sheets, you click the add-in button, you say, I want the substream add-in. Then you click the button, you say, what substream do I want? I put the URL of what the substream is that's already been predefined. You hit submit. Then it says, what data do you want from that substream? Because a substream will populate different kind of columns if you want in a spreadsheet. I want the column, populate. Great. Now I have a spreadsheet that shows all my transactions for my accountant. Great. I can do my end of year taxes. Awesome. Right. So this works. Okay. It's not really finished yet. It's a prototype, but it does work. We have shown that it works. So that's an idea that you can have using Substream. The one in the middle, Telegram bot, as things happen on chain, you can output messages to Telegram or Discord or Slack or whatever, and keep up to date with what's happening. Yaniv and the team is working on Geo's, going to be a very big Web3 application, and it's going to be powered by Substreams. So all of these applications can use Substreams today. The future, I just want you to think about the possibilities are endless here. You can use Substreams for whatever you want. You can do it in your GameFi, artificial reality, Web3 social media, tokenized real estate, whatever you want to do, you're going to be using Substreams for this. All right, let's talk about developers. Developers are key. We don't have dApps without developers. So 2 things I wanted to just touch on here is smart contracts. So a lot of smart contract developers do weird stuff in their smart contract in order so that they can get the data out using the traditional RPC. It's just weird. Well, if we have a nice consistent query layer that's available to those contract developers, then they can stop doing weird stuff in their smart contract. So make it easy for them to read the data out of the blockchain for their smart contract. And if you're Messari, for example, you need all that data in a data warehouse to do your quarterly reports for your blockchain. So yeah, sure, why not? Or you're doing AI analytics, you need all the data in a data warehouse. Sure, whatever. So we can make that happen using the power of Firehose and Substreams. So you may hear a recurring theme here. What do you want? As a developer, as an application, the sky's the limit. It's a really powerful framework that is coming to fruition here. So developers do need to learn a little bit of Rust in order to create the substreams. In our team, that started in December. Before December, probably our team didn't have any experience on Rust. And now we've built a whole bunch of prototypes like you've seen in those screenshots, and the team is busy building new things. So it's a little bit of work if you're just used to PHP development or JavaScript development, whatever. Okay, I got to learn a new thing, but you don't have to go very deep in Rust. You need to learn the basics, and then you're good to go. And then once you've got that substream written in Rust, and hopefully you'll be able to just leverage other people's stuff, so you don't have to build the whole complicated one. You're just building a simple thing. Once you've got that, then you can process the data that comes out in whatever language you want, because now it's just a gRPC protobuf. Teams are working on building, web or RESTful interfaces on this. So if you're a developer who just wants to deal with that, there's going to be lots of options for how that works. Here's just an example for developers of the GUI or TUI terminal UI of what you do when you're building a substream. So you've got a whole debug interface that's available today. And you can load, there's a few tabs there at the top. I just put one screenshot here, but request, progress, output. So you can inspect the output of your substream at any block that has already happened. You can see if you're running this live, you'll see the blocks appearing in that little progress bar in the middle. As the substream's running live, it will give you new blocks, and you can inspect what's going on. You can start at a specific block, end in a block. So it makes it easy to debug what's going on in your contract or your substream. and then make a quick change, rerun the whole thing, and check the output again. So making it easy for developers to check what's going on and make changes is really important. So shorter development cycles, faster market, more cool stuff. That's what we want. We want to get from make a change, wait 2 months, to make a change, wait 5 minutes to see what happens, repeat, right? So for the blockchain community, let's see the level of effort. Every blockchain doesn't come with Firehose support. It has to be built for that blockchain. So this is work that the core dev of that blockchain stack will need to do, or somebody else will need to do it either way. But just Firehose support doesn't come for free. So because every blockchain works kind of differently, the data format has to be aligned to the way Firehose works. So this adapter needs to be built in order to get this to work. So the level of effort to get Firehose support for any blockchain is kind of dependent on the blockchain itself. So they can use different techniques, and these techniques have all been used in the existing Firehose implementations. You could just use the old RPC methods that already exist. Get me block 1. All right, I got block 1, give me transaction 1, give me transaction 2, give me transaction 3. So you could just do get and then output a Firehose compatible data interface from that. It's possible, not ideal, but it's possible. If the chain provides a software development kit, okay, you could use that software development kit to get into all the data out of that blockchain. So that's another way to do it. Or the most powerful, but the most complicated, is modify the actual software. So if you're thinking about Ethereum, there's a modified version of Aragon, there's a modified version of Go Ethereum that know how to output the Firehose messaging format that the reader knows how to read, and then the rest of Firehose works. So it's a bit of a complicated thing to kind of get started. And really what we want as the graph community is for the individual blockchains to take responsibility of building that themselves. Until that point exists, most of the existing blockchains Firehoses have been built by the Streaming Fast team or one of the other core development teams. The Aptos team has built their own, as an example. So these things need to stay in sync with the upstream. So whenever there's a hard fork, things need to change, whatever. There's work to do here. It's not, oh, great, just do it once and then forget it. Blockchains are not just write something once and forget it. That there is ongoing upgrades that you need to handle. So a bit of work here. And just to go back to that original picture that I showed at the early part of the presentation. So the part that's unique to one blockchain is the Firehose enabled execution node. That's the part we're talking about. And then the reader component needs to know how to read it. The readers are specific to a blockchain family. So Ethereum, Polygon, BNB chain all use the same reader, but they have different Firehose execution nodes because the Polygon team has modified the standard Go Ethereum to work for Polygon, and the BNB team has done the same thing. So they have their own unique execution nodes, but they have a common reader for Ethereum. There's also a Near reader, there's an Aptos reader, there's a Philip reader, etc. Yeah, I kind of covered all this. We really want the upstream providers to provide this and not do the Firehose work as the graph community. So there will be some efforts to convince those blockchains that this is a good idea. And the more developers we can attract to Firehose and Substreams to see the power of it, and those developers start asking their blockchains, hey, dear blockchain, when are you providing Firehose for my blockchain? Then that's what we want. So like I just pasted a link here for one developer asking their community when the blockchain would be available. They just created that GitHub issue this week. In general, there is support. If you know a blockchain that wants Firehose support, the documentation is here on how to do that. And the Streaming Fast is available for a consultation, a live meeting. They can have a discussion about it. You can ask for Matt in the Streaming Fast Discord or reach out to him directly. And Matt, that's not me. That's Matt from Streaming Fast. There is help available for those blockchains who want to integrate. We definitely want the world of blockchains to all be speaking Firehose. And now for the indexers, very important community. Running blockchain infrastructure is hard. Every indexer running every blockchain, this is totally impossible, right? So as I said at the beginning, an indexer, it takes them all day just keeping up with Discord with the, less than 10 blockchains that we have to manage today. Can you imagine hundreds of blockchains? Not scalable. We can't build huge indexer teams that just do that. So the The indexers need to cooperate with each other and share their knowledge and work together. So some indexers will be experts in some things, some indexers will be indexers in other things. But at the end of the day, more indexers, more decentralization, and this is what we want. If you want to follow the discussion about where this is going, GIP 0042, A World of Data Services, is the thought process about how these indexers are all going to work together and cooperate and build comprehensive data services that is not just, GraphQL. This is where to follow the discussion. And as a visual diagram, here is just 3 indexers ABC. The first 2 indexers, are running some infrastructure. Well, indexer A is running their own infrastructure. That's all they do. They only offer subgraphs that use their own infrastructure. So they've got a Phantom archive node, they've got an Avalanche archive node, and they got a few firehoses there. So indexer A, that's what they're doing. Indexer B, it's like, well, I can run a Ethereum firehose, and I will use the Airweave firehose from indexer A. So we're going to build a world where the indexers can cooperate with each other and get paid, and it'll all be tracked through the Graph's decentralized network. And then we've got indexer C over here. Indexer C decided, never mind, I'm not going to run any graph nodes at all. I'm just going to be a firehose provider. That's totally fine too. So we're going to have different levels of indexers, different kinds of indexers offering different kinds of services. So we can think about it as, a series of dolls that all, well, I'm a little one, I'm a big one, I rely on something else, they collapse, whatever. The world of indexers is going to get much more complicated, and we're going to have a whole variety of different kinds of indexers doing different kinds of things on different kinds of blockchains. This is the future. So in summary, the firehose with substreams allows us to decouple reads from writes. So blockchain software is very good at writing data, but it's hard to read the data out in the format that the developers need. So we separated those 2 things. Blockchain software can only spend time on writing things very fast and coming to consensus on what the blockchains are, and firehose and substreams will handle the reading part. There's one data model per blockchain. We've got data completeness. The idea is we want to extract all the data out of the blockchain, so no matter what developer wants to do, they have all of the information they need. We want state changes. We want everything that the developer might want to use, we're going to extract and store in those firehose flat files. Parallel processing and powering the next set of subgraphs using substreams, which you can already do today. And of course, the whole thing is open source. To follow on more, there's a couple of presentations that I did previously for the indexer community. So Firehose for operators running Firehose the first time. So there's these 2 presentations that are available. Have a look through and you can understand what the indexers need to know about running a Firehose infrastructure. We'll do more presentations in the future if there is interest. So please speak up and ask for what you want to know about, and we'll endeavor to provide all that information. On the right side, we've created a awesome substreams GitHub, and we're trying to collect all of the different information there. That will evolve over time. We expect to see things like a substreams registry where you can find all of the various different substreams that other people have built, so that then you can build on top of them as a developer and not reinvent things over and over. So there's going to be a lot of work coming on that as well. Yeah, the future of indexing, this is a huge topic. And, talking to the other indexers, there is so much going on here, so much that we need to learn, so much that we need to work through. The only possible future, well, I guess there's 2. Building centralized services like Infura or Alchemy or whatever, or building a world where the indexers can cooperate with each other. So obviously, we want to see the second one. But the other thing that I kind of didn't mention there is we expect indexers to offer different services. So indexers will offer graph node services or GraphQL like today. Indexers will offer Firehose. Indexers will offer maybe just the RPC nodes. Maybe some developers want to just use RPCs, and that's fine too. So we want to enable indexers to offer those services. What about, we talked about all the different syncs that are available. We want to store data in a key value store. We want to store data in a data warehouse. We want to store data in, I don't know, what do people want, right? So what if indexers could provide a data warehouse feature as part of the graph ecosystem? Well, that would be cool, right? So mind exploding thing, the possibilities are endless here, and we're going to give indexers the power to, provide data to the world in a in multiple different formats. And the slide that showed that we were showing Firehose and, archive nodes, well, there's a whole lot more that can be provided there. And the discussions are early and ongoing within the core development team to understand how we're going to make that happen. It hasn't been designed yet. It's still thinking about it.